Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 5. Yesterday the class was rescheduled to today, so the same content will be discussed in the today topic. Am I audible? Dear participants, can you please confirm? Am I audible? Dear participants, can you please confirm? Am I audible? Yes. Am I audible? I'm just waiting for a reply, my dear participants. Yes, thank you. Thank you, Mr. Anand. Yes. Yes, thank you, participants. Thanks for your valuable reply. This is Malayapan from pantechelearning Private Limited. And about Pantech is an educational equipments manufacturing company. From Pantech, you will get a laboratory equipments for ECE, AAA, computers, and site-related products. You can get it. Our vision is to help the students to learn the technology in easy way. Right. So far, we have trained about 20 lakh students. Right. Right. So the announcement, you will get attendance form at 8:40 p.m. So please don't forget to submit your attendance form. Today also day 5 attendance will be shared. So you don't worry. So today attendance, yesterday those who are all came to the class for yesterday. So their attendance also will get considered. Don't worry about the attendance form, right? So this is our 30 days plan. So far we have completed 3 days, 4 days topic. So today we are going to discuss in detail about that power electronics. So which is mandatory concepts for the electric vehicle system. So that's why we took detailed discussion about this particular topic. So again we have segregated into the detail like what is a power electronics, what is a power converter design, how we can design the power converter, and how we can design the power factor correction circuits, and what is the impact on the in the EV system. So everything we have scheduled. So we will go as per our schedule. So you don't worry. Each and every class we will discuss the concepts as well as the one working model. I hope you have completed for the previous day's working model. If you are not completed, please try to complete that working model with working with MATLAB, right? Then only you can cope up the concepts with this schedule, right? So here one more announcement for you. So those who are all seeking job, so the Pantech recruits now. So the qualification BE BTech who are all completed this degree. So from this respective branch like a CSE, IT, ECE, computer science, and triple E mechanical. So those guys, you can send your resume to this number, shown number, whatever we shown in here. So you can apply, you can share your resume to this WhatsApp number. So our team will get back to you based on your resume. So till that from 2020 passed out till latest 2023 passed out, so all are eligible to attend this recruitment drive. So if you have 1 0 to 1 year experience also, you can apply. Or else without experience also, people can send your resume. So the job description is project trainee, project trainee, and location is in Chennai and Bangalore. Right. So interested can send your resume to this number. So 98409 74408 and 98409 74407. So for these two number, you can send your resume in WhatsApp. I hope you understood. Right? Yes. So the degree eligible degree is about BE BTech or MB MTech also you can apply. ME MTech also you can apply. Dear participants, am I audible? Yes. So now let's move to the topic. So here we will discuss the power electronics and what is the semiconductor, because in the power electronics domain the semiconductor is going to work in detail, and then that's only going to convert the power, right? And how we can apply the power electronic circuits, power electronic concepts to our EV system, right? And some case study we will discuss in detail. So please try to engage with the entire session. Are you ready to learn these concepts? Are you ready to learn these concepts? Are you ready to learn these concepts? If you are ready, please comment in the comment box. Ready to learn. If you are ready, please comment in the comment box. Ready to learn. If you are ready, please comment in the comment box. Ready to learn. Yes. Just give your reply. Yes. Thank you, participants. Thank you so much. Thank you for your interest. Right. So again, one more information after this live. So those who are all interested, those who are all joined with the internship, please check your email as well as that WhatsApp. WhatsApp. We have sent the Zoom link. So please join the Zoom link after this live. So this live will get closed 8:45 p.m. Right. So the power electronics is nothing but it's a circuit which combination of the solid state electronics, right? So to control and conversion of the electric power. So this is the major purpose of this power electronic circuit. Simply we can understand it's a simple electronic circuit. That circuit can handle the maximum amount of current. So that is called high power voltage as well. I mean high power voltage and high power current, right? So here we can control the both voltage as well as the current with the help of the PWM. So here the PWM will help us to control the output voltage as well as the output current. So that is the biggest advantages of this power electronic circuit. Here you can handle even 0.1 ampere to 1000 ampere, right? So those were all those circuits handling this high amount of current. That's called the power electronics. So by simply we can understand. See here, we are applying the source voltage at this moment. So here we are applying the source voltage at this moment. So this is the simple combination of electronic circuit. So here the electronic circuit is nothing but it's a active element. Active components will be placed along with the passive component. So that's why we are calling it, this is the electronic circuit. So here the controller. So the controller nothing but simply we can understand. So you suppose if you are applying 230 voltage, like 230 voltage AC or DC, and with the higher rating of amount of current 10 ampere. So let us assume this is the amount you have at the source end. So now the load requires sometimes it may be zero voltage and sometimes it may be maximum voltage. So which means that 230 voltage. So 230 voltage, right? So by changing the controller, so here let us assume this controller minimum value is 0 and maximum is 5 voltage. So this is a small amount of voltage. If the controller input is 0, then the in the output end, voltage will be 0. Suppose if the controller input is high, here the output voltage voltage at the load end will be the maximum, right? So by changing from 0 to 100, so it's not like digital inputs, right? So linearly you can increase the control voltage. So let us assume this is the 0 and so this is the maximum 5 voltage. So this signal is called the pulse width modulation. This signal, call it as a pulse width modulation. So by changing this voltage, so there actually in the controller will convert this linear voltage into the pulse width modulation. So there you should know the what is the controller. So I will tell you, and all the concepts I have listed in this series, right? I have listed one embedded system controller to generate a PWM with the MATLAB. So that concept also I have included in this series. So please try to engage with the entire session, the entire series, right? So by changing this voltage to 0 to maximum, then we can get a controlled output voltage. We can get a controlled output voltage. So this is called power electronics. I mean the entire concept. So with this different type of circuits, we are going to play from play to get any kind of output voltage. So for example, if you apply a AC, you can get a AC or DC. DC. Or else, if you are applying DC, here you can get a AC or DC. So by just changing the topology and just changing the PWM, we can get any kind of output voltage. I hope you understood, right? I hope you understood the concept of the power tolerance. Right? Do you have any questions? Do you have any questions? You just comment in the comment box. Do you have any questions? Just comment in the comment box. If you have any questions, please comment in the comment box. I hope you understood. If you understood, just comment in the comment box, super clear. If you understood the concept, just comment in the comment box, super clear. Yes, thank you participants. Thank you for your comment. So now, how we can, what is a building blocks of a controller? Yeah, I will tell you that controller information. See here, now we are applying the input like this. So here, let us take this is the input power, this is the AC power, right? So now here we have to get a controlled output voltage. Let us take a DC output power, right? So this is the DC output, right? So here we are applying AC input. So here we are going to get a DC output, right? So here in between the solid state switches has been placed. So for the controller will help the switches when the switch should on, when the switch should off. So here the blue color pulses denotes that the PWM, pulse width modulation, PWM, right? So here with the solid state switch we can get this controlled output voltage. When the PWM is high, the output voltage will be less. When the PWM is low, the output voltage will be high. So like that we can program. See here, this logic is our own logic. Whatever the logic is required, as per the demand, we can generate the logic. We can generate the controlled output voltage. From this simple information, you can easily understand. This is the input. This is the input voltage, and this is the output voltage. By just changing the PWM, we are getting the controlled output voltage. Right? Right. Thank you. Thank you for your patience. So now, what are the solid state switches? So before understanding the solid state switches, you just know the ideal switch, which means that in your home you may find this kind of switches, right? So what it means, right? When you switch on this particular switch, if you press the down button, then the switch will get connected, right? Before that, what it will happen? So it will be open circuit. So when you press towards the down, then it will get connected, right? It will get connected. So which means that, let us assume this is the point A and this is the point B. So this 2 point will get physical connection. The 2 point will get physical connection, right? Same way, this is some equivalent circuit. Similar way, so here the solid state switches nothing but it's a semiconductor switches, right? So silicon SCR nothing but the silicon control rectifier, MOSFET nothing but metal oxides, semiconductor field effect transistor, and then insulated gate bipolar transistor. Simply you can understand. See, actually in your electronic circuit you may hear the name called transistor, right? So the transistor is an active switch. Whenever you apply a PWM, so all the transistor, any kind of transistor, so the switches, the number of terminals will be 3, right? So this is terminal number 1, terminal number 2, and the terminal number 3. So like that, so it may have a 3 numbers, right? So now, if you the major terminals, let us call this is the anode. Major terminal, this is the major two terminals will be there. So one is that anode and another one is that either cathode, like the people will mention C or K, depends the notation, right? So cathode, anode, and then cathode, right? In between one more terminal will be there. So either we can call it as a base or gate. So in the power electronic circuit, let us omit this base for simple understanding purpose. I am just telling. So the gate terminal. So here the gate terminal, when whatever the voltage you are applying at this terminal gate to with respect to source. So the source always will be the ground or again cathode. K or C or S. So this is the notations of the second terminal. Right, if you are applying voltage, this is controlled voltage. Here you can apply any kind of voltage. Here you can apply the any kind of voltage, but with respect to gate to source, the voltage will be the maximum 0 to actually in the physical electronic component you can go up to 18 voltage. Depends the part number, this voltage rate may vary. This depends the part number, the voltage rate may vary. Some devices may require only 0.5 voltage, some devices may require 5 voltage, 8 voltage, 10 voltage, 12 voltage range. In any switches, the maximum voltage will be 18 voltage. Maximum switch will be the 18 voltage. Right? So I hope you understood all the concepts. So now, so how the switches are working? How the switches are working? See here, when you apply a gate to source, when you apply a voltage gate to source, see here, if there is no, for example, if you are let us take these two moments, right? So at this moment, so this is the at this moment if you apply a gate voltage is 0, so in that case there will not be any physical connection or electronic connections. So in that case the drain current will be 0, so there is no any closed circuit. When you apply a PWM at a higher rate, when you apply a high PWM, then you may get a electronic connection between the anode and then cathode. So in that case, which means that actually the physical connection has been established. So in that case, we can carry the current via the network. We can carry the current via that particular network. This is the simplest understanding of how the switches are working. So now, so what are the type of converters? So very first one is called AC to DC. So which means that we can convert AC voltage to the DC voltage. So for that we are going to use the rectifier. We can call it as a rectifier. Same way for the DC to DC converter. So either we can call it as a chopper or DC to DC converter. And the third one is that DC to AC. So that name is inverter. DC to AC. Right. So here where in electric vehicle, what are the power electronic converters applications? Right, what are the power electronic converters applications? See here, so in the electric vehicle, in the particular electric vehicle, see here, very first application is the charging station. So in the charging station, we may require the high controlled current, high controlled voltage. So here we will use the power electronic circuit. Same way, onboard charger. So here also we may require some kind of power electronic circuit to carry the voltage. And third one is that inverter drive. So here we are going to use the electric motors only, right? So in the electric motor, we may use we have to use one type of topology. That topology should generate a controlled output voltage with respect to the motor terminal. So in that situation, we may use the inverter drive and the power supply. Other than the electric motor, many other electronic circuits are there. So for that one, we have to give a voltage, right? So with that, we can apply a controlled output voltage. So that generally we can call it as a DC to DC converter or SMPS. So these are all the applications of power electronics which is used in the electric vehicle. Right. So what are the solid state switches? The solid state switches are you can take it as the basic diode, BJT, SCR, a transistor, MOSFET, IGBT, GTO, SiC, MOSFET, GaN devices. So these are all the type of devices based on the topology, power rating, and then operating frequency. We have to choose the device, any one of the suitable device. Right. So we cannot use all the devices for all the applications. For rectifier, we have to use either SCR or MOSFET for some applications. Same way for the mid-range power supply, then IGBT we have to use. For high power applications, again we have to go for the SiC MOSFETs and GTO. So these are all the different. Actually, again we have scheduled how to select the switches and all. I scheduled one more topic, so like gate drive circuit design. So in the topic we will discuss in detail about how to select the switches for the particular applications. So please engage with the entire session, right? And see here. So these are all some additional applications of the power electronics in the EV system. So bidirectional converter may require for for vehicle power transfer as well as the battery charger. And same way for the again in this topic, the Pantech will help you to help you to do the research part of it. Like if you want to develop a bidirectional converter prototyping, yes, Pantech will help you. Same way for the wireless power transfer application, Pantech will help you to develop the prototype. So for first level of prototype, we will support you. First level of prototype, we will support you, right? So in the first application rectifier, so there again we can classify uncontrolled rectifier and then controlled rectifier. Very first one is that uncontrolled rectifier. If you are using the diode, we can call it as a uncontrolled rectifier. If you are using either SCR or MOSFET, then we can call it as a controlled rectifier. Before understanding the control and the uncontrolled, you should know some basic information about the AC waveform, right? See here, if you take a sine wave, see actually AC waveform will be generally it will be a sine function, right? Some period will be the positive and some period will be the negative, right? So here we can call it as the half of the cycle will be the positive and remaining cycle will be the negative, right? So if you take a electrical angle, right, or time. So here we can separate the entire waveform into four divisions, right? 0 degree, 90 degree is the positive peak, and then 180 is the 0 degree, 0 voltage again, and 270 is the negative peak amplitude, and 360 again 0 degree, right? So if you draw the circle, the voltage will start at 0th instant and it will be positive, and it will be again for the negative period it will be there. So here the starting point, and here the ending point, right? So like that it will may vary. If you assume the input frequency is 50 Hz, then what will be the time period? So the time period formula is 1 by F. So here we took F is the 50 Hz, right? So 1 by 50 is equal to 20 milliseconds, right? 1 by 50 is equal to 20 milliseconds. So let us assume, see here, so here we are calling this is the electrical degree. So we can call it as a degree, right? So this maximum value is 360 degree. Now you have to calculate the time period for the 1 degree. So now you have to calculate the time period for the 1 degree. So what is the value of time period? So the 0 to 360, the starting time is 20 milliseconds. So this is the time period 20 milliseconds. So now what is the time period for 1 degree or 90 degree or 180 degree? So 270 degree. So how you can calculate the time value? How you can calculate the time value for particular degree? So let us assume. So just calculate the time period for 1 degree. What is the value for time? Value for 1 degree. Can you just tell? Can you just type in the comment box? How can you calculate the time period for 1 degree? How can you calculate the time period for 1 degree? Can you just comment? Can you just comment? I'm just waiting for a reply. I'm just waiting for a reply. See here we have the total time period is 20 milliseconds. Total time period is 20 milliseconds. So now you just calculate the time period for 1 degree. So the 20 milliseconds is equal to 360 degree, right? So the 20 milliseconds is equal to 360 degree. Yes. 360 divided by, not a pi by 360, not pi by 360. So just take, see here, 20 e power minus 3, right? That is the 20 milliseconds. So now we need to calculate the 360 degree. So let us take 0.02 divided by 360. So that will give you 1 degree per 1 degree value. So the 1 degree value is 5.55 e power minus 5, right? 5.55 e power 5.55 e power minus 5 seconds, or else how you can calculate. So now you just calculate. Now you just calculate the time period for 90 degree. So this is the 1 degree time value. This is the 1 degree time value. Same way, just calculate the 90 degree. So what is that 90 degree value? Simply you can just do this one. 20 e power minus 3 divided by 3. Right, for the 90 for 90 degree, so exactly 5 milliseconds, exactly 5 milliseconds. So like that you should calculate the, like that you should calculate the value, not 18 milliseconds, not the 18 milliseconds. 5 milliseconds, 9 I mean time period for 90 degree is the 5 milliseconds. Time period for the 180 degree, it will be 10 milliseconds, 10 e power minus 3. I hope you understood how you can understand, how you can analyze the sine waveform, right? Because in the power quantum circuit, always where in any circuit you should know the time period and then amplitude, right? Amplitude. So if you take a multimeter, you just put your multimeter in your wall socket. So it shows that the 270. Okay. Okay. So if you take that, if you take a multimeter, if you connect that multimeter into your wall socket, if you connect your multimeter into your wall socket, in that situation, so the multimeter will show like a 230 or 220 or something like that, right? So that value we can call it as that average value. I mean, if for AC it will be a RMS voltage. AC will be the RMS voltage. The same way, in the same way, if you connect a DSO or CRO, if you connect that CRO to your wall circuit, then what it will happen? Then what it will happen? So that shows that exact instantaneous value. So like the sine waveform, we may get it. So here the maximum voltage will be, what is the maximum voltage? The RMS voltage will be 230, right? So here the 230. So the maximum voltage will be 230 into root 2. 230 into root 2. So this is the maximum output, maximum voltage. So here we can call it as a peak voltage. Here we can call it as a peak voltage. Right? Do you have any questions? Do you have any questions? If you have any questions, please comment in the comment box. If you have any questions, just comment in the comment box. If you have any questions, just comment in the comment box. If you have any question, you just comment in the comment box. Yes. So now again, now let's come to the point. So here, if you use the, in the circuit, if you use diode alone, then we can call it as uncontrolled rectifier. If you are using SCR or MOSFET, if you SCR or MOSFET, then we can call it as a, again we can classify half wave controlled converter, full wave controlled converter, and based on the phases, single phase and then three phase converters. Single phase and then three phase converters. So these are all the type of converters widely available in the market. So now let us understand what are the functionality and how we can do this one, right? So this is a simple understanding purpose. This is the 20 milliseconds up to 360 degree, and 1 degree is value is about 5.55 e power minus 5. Same way you can calculate the value. So now let us take the uncontrolled rectifier. So in the uncontrolled combination, see here we are converting AC to DC by using the diode. So the diode, the functionality is if you apply positive voltage here and then if you apply negative voltage here, then it will get connected. If you apply negative voltage at this anode and then positive voltage at cathode, then it will connect. The diode will not get connected. It will be breakdown. It will break, right? The circuit will not get physical connection, right? So same way, during the positive cycle, input positive cycle, the circuit, the diode will act as a switch. That's why we are getting the output voltage. For example, during the negative voltage, negative sub input, the diode will act as a open circuit. The diode will act as a open circuit. That's why we are getting the zero voltage at this moment. That's why we are getting zero voltage at this moment, right? So this is the simple rectifier function. Same way you can go for the full wave rectifier also. This is the only half wave rectifier. Same way we can go for the full wave rectifier also, right? So in the AC network we can call it as a RMS voltage, whereas in the DC side we will call it as average voltage, right? Average voltage. So if you keep the multimeter across the supply, it may shows if you are applying 230 at here. So here you may get 115 voltage is the output voltage, right? So in this area will get averaged. This zero area will get average with the average input voltage. So like that we can understand the rectifier model. Same way, full wave rectifier. See here, this is the combination of full wave rectifier. So both the input half cycle, both the input two half cycles will be converted to the positive. So here, see, this is the typical input voltage. Till pi, this voltage will be the positive, right? So in that situation, so let us assume this is the positive and the negative. So here this diode will be the forward and then load, and this diode will be the again the forward and then return to the supply. Same way for the negative cycle. So here this will be the positive and this will be the negative. So in that situation, what will happen? So this D3 will be the forward bias and then load, right? So again the D2 will get returned. So here the positive, whatever we took the input from the supply, that has been returned, but always the load will be a forward. So here also positive and then here also positive. So that's why we are getting the voltage, right? I hope you understood. I hope you understood. If you have any question, please comment in the comment box. If you have any question, please comment in the comment box. Right? So we can the same way, instead of diode, if you keep the SCR, then we can call it as a controlled output voltage. So controlled output voltage. So how you can control the output voltage? How you can control the output voltage? See here in the diode there is only two terminal, right? So in diode there is only two terminals. So one is that anode and cathode. Whereas here the SCR has that one more terminal called the gate. So this is the gate. Here when you apply some voltage, so whenever the gate has the voltage, then only the diode will get connected. Otherwise it will not get connected. It will be open. See, for example, if you are applying gate voltage instead of 0 degree, if you are applying some voltage, like let us assume that 15 degree, if you are applying gate voltage at this moment, then only the load will receive a voltage. Otherwise, the load will have a zero voltage only. The load will have a zero voltage only. So that's why we are calling this as a controlled rectifier. That's why we are calling this a controlled rectifier. Right? So these are all the formulas, basic theoretical formulas. Just have a look. Same way we can develop any kind of rectifier. Right? So if you have any questions, you please comment in the comment box. I will try to give you the answers. So since 8:40, 9 o'clock, I have a Zoom, internship class. So I'm just moving to the topic. Yeah, thank you, Mr. Rom. Thank you so much. Right? If you have any questions, you just comment. I will try to give you the answers, and I will show you some basic example. I will show you some basic example. Just a second. Yeah. If you have any question, if you have any question, just share your question in the comment box. Yeah, crash course available in Pantech for BMS. Yeah, MATLAB taking much time. Okay. Sure, we will see the demo at the tomorrow session. Right? Still, the batch internship is going on. So those who are interested, really, if you need an internship, you can join the internship. So today after this live, I'm going for the Zoom class for the internship people. If you're interested, you can join that. Right? If you have any question, you please take my number, post your query to my WhatsApp number. I try to give you the answer. Alright? I will try to give you the answer. Thank you, participants. Thanks for your valuable time. So tomorrow we'll see.